Alright, we've got a function, x squared minus 8x plus 12, and we have lots of questions to answer. So let's remind ourselves that's in standard form, so the a number is equal to 1, the b number is equal to negative 8, and the c number is equal to positive 12. So number 1, what is the vertex of f of x? The vertex can be found with our formula, negative b over 2a, and then we take the answer to that and evaluate it or plug it in. So let's think about that. Opposite of b would be positive 8 divided by 2 times 1, so that's 2, and that gives us a value of 4. So the vertex is 4, and then we need the y value. So we take 4 and we plug it in to the original function, 4 squared, minus 8x plus 12. Oops, I'm not even doing any of that right. Hold on. 4 squared minus 8 times 4 plus 12. What does that come out to be? Let's see, that's 16. 8 times 4 is 32 plus 12. 16 minus 32 is negative 16. I get negative 4 out of that, so negative 4 is our vertex. The y-intercept, since it's in standard form, is just the number 12. It's the c value, so it's the number 12. I'm actually going to write that as a coordinate just for fun because we're about to make a graph out of it, but that's 0, 12. Number 3, write f of x in factored form by factoring it. In class, a lot of you guys were using the quadratic formula to find the roots, and then we use the roots to write factored form. That's a little bit trickier, but it does work. Glad you were problem solving and figuring it out. What we're looking for here are the two values that multiply to make the number 12 that add to be the number negative 8. Multiply to be 12 and add to be negative 8. Well, if you think about the number 12, it's either 1 times 12, 2 times 6, or 3 times 4. Which one of those pairs can somehow make an 8? Well, clearly 2 and 6 do, so I put 2 in here and 6 in here, or vice versa, it doesn't matter. But we do need to be careful because that's negative 8, so I'm tempted to then go, that should be negative 2 and negative 6. Notice that negative 2 times negative 6 would still make positive 12, so we are good to go there. That's done. Remember that you can actually write that in any order. It could be x minus 6, x minus 2. That's mathematically the same thing. Identify the roots. Well, the idea of the roots is what opposite of the value that you see in the parentheses. In other words, if it was x minus 6, that means the root, or the 0, is positive 6, and furthermore, positive 2. The roots as coordinates, because we're about to make a graph, remember we call these things zeros sometimes. That's because their y-coordinate is the value 0. So there's our two coordinates, and now we can go make a graph. We can put our vertex on there. Our vertex was 4, negative 4, so that would be from the center, right 4, down 4. There's our vertex. We've got the y-intercept was positive 12, or 0, 12, so that's going to be up here. And then we have the roots, 6, 0, and 2, 0. 6, 0 is over here, 2, 0 is right here, and that's generally enough to make our line. Now we'll point something out. There's actually another dot we can add to this very simply. You remember how there's this imaginary line we call the axis of symmetry going down the center of these things, and it goes through the vertex? Well, you can see up here that this dot is 4 units away from the center, so that means there's another dot 4 units over there. And now we can see we have that nice U-shaped sort of parabola that we always see. It's just nice to have that extra point, and we used symmetry to find that. Alright, number 7, write this in vertex form. Vertex form, if you recall, was the a number, if there is one, times x minus h squared plus k, where h and k come from the vertex. Well, the vertex, again, was 4, negative 4, so as far as our vertex form goes, we put those numbers in here and here. Technically, the parentheses would say x minus 4 because, once again, what you see in the parentheses is sort of opposite of what goes into it. The formula has a built-in minus sign. You're plugging in a positive number, so it just tracks right down to there. The a number, is there an a number? Well, if I go back up top, the a number was 1, so technically we can go down here and put a 1 in front, although most people wouldn't. So anyway, vertex form, f of x equals x minus 4 squared minus 4. Done there. Okay, we've got some ACT problems back here. Number 7, we have, it says mines frequently fill with water. Before an abandoned mine can be reopened, the water must be pumped out. The size of the pump required depends on the depth of the mine. So that's kind of announcing some variables. The size of the pump required depends on the depth of the mine. So sounds like the depth of the mine is going to be our, normally what we think of as our x value. It says if pumping out a mine that is d feet deep requires a pump that pumps a minimum of, and then we've got this formula that's kind of the y value where it's going to calculate what size pump apparently that we need. Pumping out a mine that is 150 feet deep would require a pump that pumps a minimum of how many gallons per minute. So basically, here's a value they're giving you. That's a d value, and our formula has a d in it. So 150 squared over 25 plus 4 times 150, and then minus 250. Calculator would be handy here. I know that this is 600, but right offhand I don't know what 150 squared is. So 150 squared divided by 25 in front, that gives me 900. So 900 plus 600 minus 250, that's going to be 1250. Boom, letter D. All right, moving on. Number 8. The length in inches of a box is 3 inches less than twice its width. That's a major algebra equation right there. The length of a box is 3 less than twice the width. We're going to need to interpret that. Which of the following gives the length in inches? So which one of those statements down there does that fit to? 3 inches less than twice the width. Less than means subtract. So 3, you might be tempted to write 3 minus twice the width, that'd be 2 times the width, but that's actually not right because the phrase less than needs to reverse, so it's actually 2w minus 3. If you think about that phrase less than, hopefully your Algebra 1 teacher pointed that out to you, but the less than is sort of a backwards type of statement. So we get this as an answer. If you want some explanations on the phrase less than, please ask about it in class. We'll talk about it in the future. Just going to keep the video going here. Number 9. Okay, number 9, we have a quadrilateral PQRS, and we know a couple of its sides are parallel. Here's the danger. As you look at this problem, we know that PS is parallel to QR. That's true. But it says up here that that's a quadrilateral. Well, that just means four-sided shape, which means we can't necessarily trust our eyes. You currently are looking at this picture and you're thinking, oh, like this angle and this angle should be the same. So I thought maybe, X should be the same as that angle, 112. But you look at that, and that's not even one of our answer choices. It's a good thing it's not, or else I would have chosen it. And then you're thinking, oh, if that's 70 as well. It's just not the way it works. In fact, the picture is just really not to scale like it's supposed to. If you learned in geometry that if this picture was a parallelogram, then these two angles would add up to 180, and you can see that that's actually a little bit bigger. So the correct version of the picture looks more like this. Something like that. So all we really then know, this 112 has absolutely nothing to do with the problem, so you just scratch that out from your memory. What does matter is that number 70 right there. And the idea here is that we have two parallel lines, and this line right here, which I'm extending, is what you learned in geometry. It was called a transversal. And when you have two lines, two parallel lines that are cut by a transversal, the inside angles are, in this case, what do they call those? I want to say corresponding angles. It's been a little while in my vocabulary, but it turns out that's 110 over there, so that's D. And I think we're done at this point. Hope that helps. Good job.